Hello students, welcome back to Learning Science Q&A. Today we are here with another lecture from class 9th Structure of Atom and from Atom and Molecule. Students, this would be our lecture number 6. We have already seen the atomic numbers of different elements during our last lecture. Now today we are going to start with the molecules of the element. An element can form molecule in two different ways. First is by combining similar type of atom in one or more than one number. For example, helium. Helium is made up of only one atom, that is helium itself. Whereas oxygen is made up of two atoms of oxygen. So, helium is stable in the form of helium only, while oxygen is more stable when it is occurring as O2. Atom of different element can also combine together in a fixed proportion. For example, a water molecule is made up of two atoms of hydrogen and one atom of oxygen. Similarly, a molecule of NaCl or salt is made up of one atom of sodium and one atom of chlorine. So, molecules are stabler than the atoms. Why is there is a need of forming a molecule? Because molecule will be relatively more stable than the atom itself. Considering the example of oxygen being highly electronegative. In fact, the most electronegative after fluorine. So it is more stable when it is found in the form of oxygen molecule. So this brings us to the atomicity. Atomicity is the number of atoms which are present in the molecule of an element. Let's see this table. All elements that can exist as their atom, especially are inert elements. They are all monoatomic, like argon, helium. Elements that are occurring as two atoms present in a molecule are diatomic. Oxygen, hydrogen, nitrogen, chlorine. They are more stable in this form. We can have tetraatomic as phosphorus, which is occurring as P4. It has a tetrahedral shape. Also, sulfur occurs as a polyatomic molecule, which is S8. It is a W kind of shape. Now, when we are writing chemical formulae for different molecules, we need to know certain things. Valency of an element can be used to find out how an atom of an element will combine with the other atoms of different element when they are forming a chemical compound. At this time, the valency or the charge which are present on the element or their ion must be in balance. That means a molecule is neutral. The number or the value of positive charge must be equal to the negative charge. When a compound is made up of a metal and a non-metal combining together to form a compound, the name or the symbol is written as metal followed by the non-metal. That means in a compound common salt made by Na and Cl, Na will be written first and chlorine will be written next. That means metal is always followed by the non-metal. When a compound is formed with a polyatomic ions, the number of ions present in the compound is indicated by enclosing the formula of ion in a bracket. and writing the number of ion outside the bracket. Suppose we are writing magnesium hydroxide. So magnesium is basically combining with the two OH molecules, right? So while writing the formula, we will just write OH in the bracket like this. And this signifies that two OH are combining with one atom of magnesium. So while writing chemical formulae, we must take into consideration the symbol and the atomic charge or the electrical charge present on the ion. Charge present on any ion can be positive or negative depending upon the number of their valence shell. Most of the time, in fact, all the time, metal form positive ion and non-metals form negative ion. The number of positives or negative over a element shows its valency or it shows its charge. That means sodium, which is Na plus, has lost one electron and has become Na plus. This simply means that this electron can be donated to any element that is in a need of one electron. So this is the reason why we are having chemical compound between sodium and chlorine like NaCl. So in this way only we have different name of the ion, their symbol along with their charge like sodium, potassium, silver, copper. They have plus one charge over them. Magnesium, calcium, zinc, iron and copper. They are having plus 2 charge over them in most of the case. Please note copper can form 2 valency, can show 2 valency just because it is a transition metal. Transition metal can show variable valency. Same applies for iron. Iron can show plus 2 and plus 3 charge over it. Aluminium is having plus 3 and iron can form ferric ion as well as ferrous ion depending upon the number of electron lost by the element iron. Similarly, some non-metallic element can also form ion such as hydrogen can form H plus ion, very commonly known as proton, or it can form hydride, which is H negative, least common. Chloride, bromide, and iodide, they are having minus one charge over them. Oxide, sulfide, they are having 2 minus charge over them. Similarly, we have nitrite. We are also having some polyatomic ion that simply says that these are basically some molecular forms which are present as ion. Like we are having ammonia which can be converted into NH4 positive ion. So whenever this ammonium ion is combining, it will look for someone which is having just opposite charge to this ammonium ion. That means considering the example of chloride ion, this ammonium can form a compound like ammonium chloride NH4Cl. Similarly, if we are talking about sodium and OH negative, we can easily have a compound like NaOH. What I mean to say, if they are occurring as a polyatomic ion or they are occurring as a simple atomic ion, in that case also, the charge over the ions must be taken into consideration when you are writing a chemical formula. These ions will be combining as a single identity. They will be a single entity while combining to form a compound. Now let's see some more examples. We have few examples written on the screen. Now lithium is having plus 1 charge over it. Chloride is having minus 1 charge over it. If you want to write the chemical formulae, we need to write their valency or their charge just below them or over them, and then you can cross multiply the charges. If we have only one charge over each of the element, we don't need to write charge as the subscription or the number of atom combining in the compound. We can simply write LiCl. The same concept applies for HCl. We have one here and one here, and by combining we get HCl, which is the hydrochloride. Exactly in the same way, we have NaCl that can be formed into a compound Na plus Cl negative. Here we have one charge which is plus. Here also we have one charge which is just opposite. By cross multiplying their number of atom, we get NaCl. Coming to next set of compounds, we have MgCl2. How it can be formed? Mg being 2 plus, we can see the valency here. We have the charge 2 plus. Chlorine or the chloride ion being minus 1 charge, its charge would be written like this. By cross multiplying their charge, what you get is MgCl2. Similarly, the similar case applies for ZnCl2. Zinc is also having charge plus 2, so we can write 2 here. Chlorine again having charge minus 1, we can write 1 here, and the compound becomes ZnCl2, zinc chloride. And in the same way, copper sulfate can also be formed. There is one more way of understanding these chemical formula writing. Just understand it in this way. We have plus 2 charge on magnesium and minus 1 charge present over the chlorine. Chlorine can take one electron from any element that is available to donate. But magnesium can give maximum of 2. So to take 2 electrons which are present in extra with the magnesium, how many chlorine will be required? So basically, one magnesium is donating one electron each to chlorine atoms. And in this way, we are forming magnesium chloride. Let's take an example with some other ion that is having similar valency. Mg is having plus 2 charge. SO4 as a ion. Just see here. SO4 as an ion is having charge minus 2. Now in this case, the 2 electron lost or donated by magnesium will be taken by one molecule of sulfate, and our compound becomes MgSO4. So always remember, the number of electron donated as well as the number of electron taken or accepted must be in balance. Let's look at some more example. We have PCl5. Phosphorus can have 5 valency and chlorine has valency as 1. By crossing their valencies, we have compound like PCl5. Similarly, ammonium as an ion can form NH4 positive ion having valency plus 1 and sulfate as an ion has valency minus 2. So by crossing their valency, what we get is ammonium whole twice SO4, which will be ammonium sulfate. Similar case is with the sodium, which is having valency 1 and sulfate can take 2 electron maximum. So to combine sodium with sulfate, what we need to have is 2 molecules of 2 molecules of sodium will be required to combine with sulfate, and this would become Na2SO4. So while writing chemical formula, valency and the charge over the ions has to be considered. Now next, coming to the last topic of the chapter, molecular mass. So molecular mass is expressed in the form of atomic mass unit earlier and now as unified mass, which is represented as U. For example, if you want to calculate the molecular mass of HNO3, then the individual atomic masses of the elements combining to form molecule HNO3 will be added. Atomic mass of hydrogen equal to 1 unit, atomic mass of nitrogen equals to 14 unit, and atomic mass of oxygen is 16 unit each. We are having 3 oxygen atom in the HNO3 molecule. So when these are added, we get 63 unit in total. Coming to the mole concept, the molecular formula of any compound can also be used to calculate the mole concept. Just see in what way we can use it. Molecular formula of NH4 to SO4, that means the ammonium sulfate, will be used to calculate the molecular mass of the compound in the same way we have calculated the earlier mass also. It would be represented in the form of mole. That means 1 mole of ammonium sulfate will be having 132 gram or unit of ammonium sulfate. The change will be their way of representation. Let's understand it more clearly. Mole is a numerical quantity that has a mass equal to the atomic or the molecular mass of the species. Now, the 1 mole of HNO3 will have 63 unit of HNO3. Similar way, 1 mole of NH4 to SO4 will have 132 unit of ammonium sulfate. So this is the way we represent mole of any compound. So it is the numerical quantity. 1 mole of any substance has a fixed number of particles, and these particles can be atom, ion or molecule. So these number of particle is around 6.022 into 10 raised to the power 23. So if we are talking about the atoms, then 1 mole will have this number of atom. If we are talking about any ion, So 1 mole of that ion will have this number of ions. And if we are talking about 1 mole of any molecule, so 1 mole of any molecule will have 6.022 into 10 raised to power 23 number of molecules. More conveniently, this 1 mole is also known as Avogadro number or the Avogadro constant and also expressed as N naught. Now, mass of 1 mole. Any substance which is present in the form of mass which is 1 mole is equal to its atomic mass or the molecular mass which is expressed in grams. If we are talking about the gram atomic mass of a substance, the atomic mass of a substance is expressed in the form of grams. Similarly, if we are talking about the gram molecular mass of a substance, then molecular mass of the substance will be expressed in the form of grams. That means substance mass, when it is expressed in grams, it can be considered as the mass of 1 mole of that substance. Let's take an example. Atomic mass of sulfur is 32 unit. So the gram atomic mass of sulfur will be 32 gram. And that would also mean that 1 mole of sulfur will have 6.022 into 10 raised to power 23 atoms of sulfur. The same applies for any compound also. Molecular mass of carbon dioxide is 44 gram. It can be calculated as mass of carbon being 12 and mass of oxygen 16 into 2. So, molecular mass of carbon dioxide is 44 gram. So, the 1 mole of carbon dioxide will have 6.022 into 10 raised to power 23 number of carbon dioxide molecule. So these numbers are expressed in the form of gram. So students, with this we come to an end to this chapter. If you are watching this video, please like, share and subscribe the channel. Thank you.